guys, I was told I needed a little intro to these videos, so there's your song, and I'm coming to you from the geometry class at RJHS. This is Mrs. Hale. Let's look at these notes. Alright, so on the topic 12 skills review, the first few problems you're asked to write a rule using the coordinate notation to describe the dilation. Since it does not tell us the center of dilation, we must assume that we are dilating from the origin. When you dilate from the origin, all of your points have coordinates that are going to be multiplied by your scale factor. So whatever your scale factor is what you multiply by the x coordinate and the y coordinate of your point. So on the first one, you really have to make sure that you pay attention to which ones of your points have those prime markings, because that's your image. The one without the prime markings is what you're starting with. So for instance, if I look at R, that is a original point or a pre-image point because it does not have a prime symbol. So I'm going to see how far it is from my center of dilation, the origin, and I'm going to then see how far my image point is. And then remember, when you write the scale factor, you always put the image over the original or pre-image. Image over the pre-image. So from the origin to get to R, I have to go to the right 2 and up 2. To get to R prime, I have to go right 4 and up 4. So a horizontal distance of 4 was the image when the original was 2. Same for the vertical change. The image was 4, the original was 2. So that tells me my scale factor when I reduce that is a 2. So all the points in my image are twice as far from the origin as the original points. So the way that I'm going to write that coordinate notation rule is 2x, 2y, because my scale factor is 2. So that's what goes in front of the x and the y. Now on number 2, I noticed that the figure with the prime symbols is actually smaller than the one that does not. So remember, that reminds me that my scale factor should be less than 1. All of these points are closer to the origin than the original points were. So when I look at how far S is from the origin, I go to the right 1 and up 2. But when I go to S prime, I only go to the right 1/2, and I only go up 1. So if I go, that sneeze, excuse me, to the right 1/2 for my image, excuse me, and I go to the right 1 for my original, if you were to divide that in your calculator and write that as a fraction, it is 1/2. The vertical distance for the image is up 1 for the image, but it was up 2 for the original. So again, that just agrees with understanding that the scale factor is 1/2. You can look at the other points as well. To go to R, you go over 4. To go over to R prime, you go over 2. When you put the image over the original, 2 over 4 reduces to 1/2. So all of these will verify that my scale factor is 1/2. So I would just write my rule as 1/2 x, 1/2 y. So on the next two, you're finding the actual coordinates of the vertice, of all the vertices after you do the dilation that is described. And then you're going to graph the image. So we're going to dilate this triangle using a scale factor of 1/2. So remember, there's two things that should occur. The figure should be getting smaller since our scale factor is less than 1. It should also be getting closer to the center of dilation. Again, it doesn't tell me what the center of dilation is, so again we have to assume when it does not tell us that we're going to dilate from the origin. So I'm going to look at every single point's distance from the origin, and I'm going to cut that distance in half. So C from the origin is to the right 3 units. So instead of going over 3, I'm going to go over half of that, which is 1.5 or 1.5 or 3 halves, however you want to say that. And so remember, this point is C prime with the prime notation because it's the image point. So the coordinates of C prime, the x is 1.5 or 1.5 or 3 halves, however you want to put that. The y, since there's no up and down movement, is 0. Remember your center dilation, your original point, and your image should be all on the same line. So I'm going to do the same thing with B and D. To go from the origin to B, I have to go down 2 and to the right 1. So I'm going to cut those distances in half. Instead of going down 2, I'm going to go down 1. Instead of going over to the right 1, I'm only going to go over 1/2. So here is the location of B with the prime symbol since it's the image. Again, I can see the origin, my original B, and my new B are all in a line together. The coordinates of that point from the origin, you would go right 1/2, so the x is 0.5 or 1/2, and the y coordinate, you go down 1, so it'd be -1. Now we're going to do D. To go from the origin to D, we have to go to the right 1, 2, 3, 4, 5, and down 1, 2, 3. So I'm going to cut those distances in half. Instead of going to the right 5, I'm only going to go over half of that. So 2.5, 1, 2, 2.5, or 5/2. Instead of going down 3, I'm going to cut that in half and go down only 1 1/2. So here is where D prime is going to be located. Again, the origin, D, and D prime are all on a straight line together. The coordinates of D prime would be 2.5 or 2.5 for the x, down, so a negative y of 1.5. Don't forget the negative sign since it was down. The next one is a dilation with a scale factor of 4. Still doesn't tell us from which point, so we're going to assume the origin. Now my figure should be getting bigger, and it should be getting farther away, each one of the points from the origin. So I'm going to count the distance from the origin of each point, and we're going to multiply those distances by 4. So S is 1 unit to the right, so when I multiply that by 4, I'm going to go 4 units from the right, from the origin. 1, 2, 3, 4. So this is where S prime, which you use this prime symbol, is located, and that's the point 4, 0. T from the origin is up 1, left 1, so I'm going to multiply those distances by 4. So from the origin, instead of going up 1, I'm going to go up 4. Instead of going left 1, I'm going to go left 4. So the coordinates, which that is T prime, would be, my x would be -4, my y would be +4. And finally, U from the origin is only left 1 unit, so I'm going to multiply that by 4 and go left 4 units. So this is my U prime. So the coordinates of that point are -4, 0. One thing I failed to do on the first triangle, so we'll go back and do that, is to graph the image. I did graph the points, but I do need to connect those because the original image was a triangle, not just 3 points. And I'm just freehanding these, but you could definitely use a ruler and make those look a whole lot nicer than I just did. Remember to always double check that your center dilation, your original point, and your image are in a straight line, which is the case for all of ours. Remember, you should be able to take the original point, like S was 1, 0. If you put the image over the original, you would get, well, not with the zeros, but with the 4/1, you would get the dilation scale factor, which was 4. So just a double checking there. On number 5, you're stating if the polygons are similar, so on your homework, make sure you circle yes or no. If you answer yes, you're going to give a scale factor. If they're not, of course, you won't give a scale factor. So remember, by definition, similar figures have to have all corresponding angles that are congruent and all corresponding sides that are proportional. So let's look at the angles first. I'm given that this angle is 135 in that figure and that this angle is 45 in this figure. Notice the arrows tell us that the opposite sides are parallel. So anytime we have opposite sides parallel, we have those relationships that we have already learned that we know to be true. We don't have any alternate interior angles because we can't make a Z since we don't go on the outside here. But we do have those same side interior angles. These would be same side, this angle and this angle. Notice I didn't mark them as being congruent because that would not make sense for an obtuse angle to be congruent to acute. But we do know that same side interior angles are supplementary, which means they have to add to be 180. So if that one is 135, then this one would have to be 45 degrees for those to be supplementary. These are also same side interior, so this one would have to be 135. These are also same side interior, so this one has to be 45. So if you do the same relationship in the other figure, then of course you get the same relationships in this parallelogram as you do here. So we do have all the corresponding angles that are congruent. Now we want to check the corresponding sides. Now, it doesn't matter which order you write the ratios to check if they're similar, but if they are, we're going to have to write the scale factor. And so remember, to write the scale factor, you always put the image over the original. So I'm going to do that when I'm checking, just so if they are, I'll already have my scale factor. So when you're trying to decide which sides correspond to each other, this parallelogram has a shorter side and a longer side. The shorter side of this one would have to correspond to the shorter side of the other figure. So when you're doing your comparisons, you would compare the 8 and the 4, not the 8 and the 5. The shorter sides would go together, the longer sides. This, I'm assuming, is my image since it's the second figure. So I can see it's getting smaller. So if they are similar, I know my scale factor is less than 1. So I'm going to put the image length, 5, over the original length, 10, because those are the sides that correspond. And I want to know, is that equal to the other ratio of the corresponding sides, which would be 4 to the 8. Well, those both reduce to 1/2. You can also cross multiply to see if you get the same product. 5 times 8 is 40, 4 times 10 is 40. So either way, yes, my two figures are similar. The corresponding angles are congruent, the corresponding sides are proportional. My scale factor, since I already have these written as image over original, I would just need to simplify those fractions. So I would write my scale factor as 1/2. On the next set of problems, you don't have to determine if they're similar. They are similar. You're trying to find the side that is missing. So wherever the question mark is, you can think of that as your x. So here is where you're going to set up that proportion, but you're not going to have all 4 of the numbers. One of them is going to be your unknown. So again, I know the long sides have to correspond and the short sides have to correspond. It doesn't matter if you write it image over original this time because you're not writing your scale factor. So if I want to put the x on top, even though it's the original figure, that's fine. What side does it correspond to? The short side of the other rectangle. In the other ratio, since I started with this rectangle, I would want to put the 35 on top, and then the other side that it corresponds to is the 14. So we would want to do our cross multiplication at that time. X times 14 is 14x. 6 times 35 is 210. So we would undo the multiplication of 14 and x by dividing by 14 on both sides. And so we should get x is equal to 15. There were no units that were given, so it's just 15 units, whatever that the case may be. All right, good luck. Talk to you later.